Welcome. We will start discussing about the remaining part from our lecture of intake and nozzle. We had covered for the intakes. Now we will discuss about the nozzle. So the nozzle which we are going to talk about is called as propelling nozzle. Actually there is nozzle in the gas turbine power plant, and that nozzle is exclusively used for generating the jet. Then the nozzle is called as propelling nozzle. If the nozzle is used in the turbine as a component, then that is also a nozzle. So practically there are two nozzles in the gas turbine power plant, about which rather from which we are going to talk about the propelling nozzle, which is exclusively used for generating the thrust. So we know that a typical gas turbine power plant has compressor. It has state 1 at the inlet, it has state 2 at the outlet, then we have combustion chamber. After the combustion chamber we have gas turbine, which has process 3 to 4, and from the 4 we have nozzle from 4 to 5. So we are talking about the process 4 to 5 in the nozzle, and objective of the nozzle in general is to act as a duct which would decrease the pressure and increase the kinetic energy. So if we plot the TS diagram for process 4 to 5, then this TS diagram would depend upon a factor which is related with choking. And what does it mean by choking? We had already seen in one of the classes where we came to know that mass flow rate in the nozzle doesn't increase if at all we decrease the nozzle exit pressure, and in that choking case the minimum cross section or the throat has attained the Mach 1 or sonic condition. So in general in this cruise subsonic aircrafts, the nozzles are convergent, where maximum Mach number is expected to be sonic at the exit, which is going to be attained after having choking state. So this is, suppose, the entry to the nozzle, which is not 4 total conditions at the exit of the turbine, and then from the 4 we generally come to static state, which is 5. We are using total conditions at the entry and we are using static conditions at the exit. This has a relevance which states that H naught is equal to H plus V square by 2, where it is the total enthalpy at the entry to the inlet of the nozzle, and this is the static enthalpy at the outlet of the nozzle. So H naught minus H is the kinetic energy which is available at the outlet under the assumption that entry kinetic energy is negligible. So we are moving from H naught to H. So practically H naught 4 to H5 is equal to V5 square by 2, and in our language it is Cj square by 2. So we are interested in finding out the jet velocity. So we are putting this process from stagnation condition to static condition only, which is unlike in the case of compressor or turbine, where we have all the graphs between total to total condition or stagnation to stagnation condition. So this process is this way, but in reality we will have a process which is 4 to 5. So this is 5 dash and this is 5, but the nozzle is not going to operate as an isentropic duct. There is a loss in due to friction, due to which we are having this dotted line, which is real expansion in the nozzle. However, the nozzle is an adiabatic duct, due to which the total temperature at the inlet and at the outlet are same. So this is not 5 condition, which is corresponding to the total condition at 0.5. Here this TS diagram suggests that we are working with a nozzle where PA is equal to P5 and nozzle has completely expanded the gas, whether it is subsonic or supersonic expansion, but there is complete expansion, and at the exit the fluid has attained the pressure which is equal to the pressure of the ambience. However, in the choking condition this graph would get altered, and then we need to bring in the choking pressure also into the figure. So we are here in not 4 state. So this is P04, this is P05. So gas expands from 04 till 5 dash isentropically. However, it has crossed PC, which is isentropic choking state. Okay, so since it has crossed the choking state, so the pressure is further lower, and then it is, for us it is C dash. Now atmospheric condition are basically there, and then nozzle exit has not attained the atmospheric pressure. Nozzle should again expand the gas, but it is insufficient to expand the gas, hence the nozzle exit pressure is more than the atmospheric pressure. So it has crossed the choking condition, but it has not attained the pressure which is required at the exit. However, still there is the process which is in real, which is after the choking. In reality it would not have C dash state, it will have state C. So this is T and this is S. So this figure has relevance when P5 is equal to PA, which is greater than PC, where however isentropic expansion, if it would have continued and then the nozzle exit would have attained C pressure, PC pressure, then it would have choked, but atmospheric pressure is more than the choking pressure. So P04 upon PA is less than P04 upon PC. So this nozzle is unchoked. However, in this case PC is less than PA, PC is greater than PA, and we have P04 upon PA is greater than P04 upon PC, and so this is choked nozzle. Having said this, we will work out with the efficiency of this nozzle. So let us define an J as nozzle efficiency, which is also called as isentropic efficiency of propelling nozzle or just nozzle. This is going to be defined from our reference figure here. If we take this figure, we are expanding from state 04 to 5 instead of 04 to 5 dash. So this efficiency has formula which is T04 minus T5, which is actual expansion, divided by T04 minus T5 dash. So this has relevance with actual kinetic energy gained in the nozzle expansion, and this has relevance with ideal kinetic energy gained in the nozzle. So having said this, we can write down T04 minus T5 is equal to 1 upon Nj into T04 T naught 4 minus T naught 5 is equal to nozzle efficiency into T naught 4 minus T5 dash. We can take T naught 4 common and then 1 minus T5 dash upon T naught 4. Then this is an isentropic relation which is having relevance with T5 dash upon T naught 4 is equal to P5 upon P naught 4 bracket raised to gamma minus 1 upon gamma. So T naught 4 minus T5 is equal to Nj T naught 4 1 minus P5 upon P naught 4 bracket raised to gamma minus 1 upon gamma. Thus, as it is said, this is equal to half Cj square. So, using this nozzle efficiency, turbine exit total temperature and the conditions where we have P5 is equal to PA, which is ambience condition, and total pressure at the exit of the turbine, we can calculate the jet exit velocity, which is required further for calculation of the thrust, where we know thrust is equal to mass flow rate into Cj minus Ca in the case of complete expansion of the gas. However, in case of choking, we would have little difference. In case of choking, we have Nj is equal to T naught 4 minus Tc divided by T naught 4 minus Tc dash. So let us write down T naught 4 minus Tc dash is equal to 1 upon Nj T naught 4 minus Tc. So we can write down Tc dash is equal to T naught 4 minus Nj into T naught 4 minus Tc. Here, since nozzle has got choked, we are unable to know what is this temperature, where this is a Pc pressure. Pc is equal to Pc dash. We would not know what is the exit pressure, and we also would not know what is the temperature which otherwise would have attained by the gas. So we are writing down an expression for Tc dash, which is equal to T naught 4 minus 1 upon Nj into T naught 4 minus Tc. Here we can use, suppose we will replot the Ts diagram for nozzle. Where this is naught 4, this is C dash, C and naught 5. Here we are interested to find out the choking condition, so we should know what is the choking pressure in which nozzle would get choked. So we are interested in finding out. We will number this equation as 1 Pc dash upon P naught 4 for given P naught 4 in which Pc or Pc dash nozzle would get choked. So this is Pc upon P naught 4, and this can be found out from Tc dash upon T naught 4 bracket raised to gamma upon gamma minus 1. Here we can put Tc dash from expression 1. So we can write down Pc dash upon P naught 4 is equal to Pc upon P naught 4 is equal to, instead of Tc dash we can write T naught 4 minus 1 upon Nj into T naught 4 minus Tc into 1 upon T naught 4 bracket raised to gamma upon gamma minus 1. So we can get PC is equal to PC dash. For given P naught 4, we can further take T naught 4 common, which would get cancelled with existing T naught 4 from the denominator and lead to 1 minus 1 upon Nj into 1 minus Tc upon T naught 4 bracket raised to gamma upon gamma minus 1. Here we should also note that since the nozzle process or process in the nozzle is adiabatic, we have T naught 4 is equal to T5. So Pc is equal to Pc dash is equal to P naught 4 is equal to P naught 4 into 1 minus Nj into 1 minus Tc upon T naught 5 bracket raised to gamma upon gamma minus 1. Here if we see closely the process C and not 5 or not 5 to C, if we isentropically compress or if we isentropically expand from not 5 to C, then we have got the Mach number 1 existing at state 1. So we can utilize this from knowing the Mach number in reality equal to 1. For choking, we have T naught 5 upon Tc is equal to 1 plus gamma minus 1 by 2, which is MC choking Mach number square, but choking Mach number is 1. So 1 plus gamma minus 1 by 2, which is gamma plus 1 by 2. So we can write down Pc is equal to Pc dash is equal to P naught 4 into 1 minus 1 upon Nj into 1 minus 2 upon gamma plus 1 bracket raised to gamma upon gamma minus 1. So this leads to P naught 4 into 1 minus 1 upon Nj into gamma minus 1 upon gamma plus 1 into bracket raised to gamma upon gamma minus 1. So in all we have an expression which states that P naught 4 upon Pc or P naught 4 upon Pc dash is equal to 1 minus 1 upon Nj into gamma minus 1 upon gamma plus 1 bracket raised to minus gamma upon gamma plus gamma minus 1. So this formula should be used to find out the choking condition for given P naught 4 for a nozzle, and once we attain, if we have pressure Pc which is lower than the exit pressure, then it is not choked. If Pc is higher than the exit pressure, then it is choked. So for that we actually can also understand that if nozzle efficiency is 100%, then P naught 4 upon Pc is equal to 1 minus gamma minus 1 upon gamma plus 1 bracket raised to minus gamma upon gamma minus 1. So which would lead to gamma plus 1 2 upon gamma plus 1 bracket raised to minus gamma upon gamma minus 1, and this is the isentropic relation between the static and total pressure for Mach number 1. So here was the discussion for nozzle and the associated things. This is how we end the topic about discussion for the propelling nozzle. Thank you.